Hello, class. Um, this is Kinesiology 3010. We're going to go into our chapter for week 2. This is chapter 3 from your textbook. We're going to start out with descriptive statistics and go into a little bit of normal distribution. We'll go through central tendency. We'll go through a few of these topics. Okay. So why do we use statistics? Statistics are here to help us analyze and interpret the data that we collect in our measurements and our tests. We can use these to standardize scores, create criteria, compare other individuals, and interpret the research within our field. You'll see, especially in your lab, when you read through your article that you have to read, you'll look at how they use statistics to interpret research within the field, the data they collect, and give it meaning, give it value, what's important, what's compared, what's related to different, what data is related to other data, and how can we make predictions to improve the quality of life or improve movement or whatever we're trying to do within the field of kinesiology. Okay, so within these statistics, we use mathematics and we use variables. A variable is an unknown. It's something that can change. When you went through your survey, each variable was each question. So how many days of physical activity did you participate in? Your height, your weight, your age. Those vary between individuals. Those are our variables. And then the value that we give, or the measurement that we get from each individual, is their assigned variable, or their number that quantifies their attribute. Some examples: age, number of push-ups, and then each person is given a number or a participant ID number, because we're not going to use names. In research, we use numbers. We have to blind those individuals for safety purposes, ethical purposes. So each individual, each participant will have their own assigned number. You'll see in a little bit when we go through these. Okay, so descriptive statistics help us summarize, help us organize, help us simplify the data so that we can really see what's going on, and then we can then begin to use other statistics to compare or associate different variables. So things that are descriptive are like percentages, averages, frequency, or cases seen most often. So if we think about your free throw percentage in basketball or your average score on an exam, those describe what's going on. It doesn't give us a comparison. It doesn't help us associate or relate different things. Or we're not able to see deeper, but we're able to see what's going on the surface. Cases seen most often, most frequently. So which type of physical activity did your participants most frequently state that they participated in? Was it walking? Was it resistance training? What was it? These are descriptive statistics. We'll go into that in our lab section and calculate some of these descriptive statistics. Okay. Within these statistics, we have different scales of measurements or types of measurements. So we have nominal scale, which is like categorical, ordinal scale, which we rank based on order compared to each other. And then we have continuous scale. These are the ones we can use mathematical interpretations with. So interval scale and ratio scale. Interval scale, we use all numbers. Each number will identify a specific attribute. Ratio scale, we have a specific zero or starting point, and then all of those numbers move from that individual point. So nominal scale, these are like categories, classifications, and we're not going to use quantitative comparisons. We'll get into what those are. We're going to use more qualitative. Some examples would be sex, so male, female, other, race, event, breed of dog, whatever you're specifying, whatever you're categorizing. One is not better than the other. One is not more, one is not less. They are all their own category. So we'll often use frequencies for these, or which is seen most often within a population. So here's an example here of individuals, 8 individuals, 8 different participants. They're each given their own ID number with each of the variable that associates with them. So gender or sex, race, high school, and physical activity type. These are all nominal scales. Okay, one is not better than the other, one is not greater, one is not less than. They are each individuals that describe that participant. Ordinal scale gives us an order. Okay, so we rank based on those observations. So first, second, third, last. So think about like NCAA rankings in football, which team is ranked number 1, ranked number 2. If you think about class rank, who is first, who is second, who is third. It doesn't tell us how different those numbers are. Okay? It doesn't say that 1 is only one value different than 2. Okay? Because if we have a ranking, say we have a ranking in class and one student has 100%, the next student, so student number 2 has a 90%, student 3 has an 89%. 1, 2, and 3 are all in that order, but the difference could be greater for some than others. So this gives us just an example of which is at the top, which is at the bottom, and which location we are in between compared to each other, compared to if we were using something like a continuous scale, where we have continuous numbers. Each number is a specific unit away from each other. 1 to 2 is 1 unit, 2 to 3 is 1 unit. So these continuous scale numbers are ones that can be added, subtracted, divided. These are the ones where we use more of our complex statistical analysis to compare, to associate, to predict based on these values. And these include both interval and ratio scale measurements. We'll go a little deeper into what each of those are. So an interval scale measurement has each unit is an equal distance from each other, and there is a definitive separation, and 0 is a part of that. So think of it as a number line. So 0 is a measurement of none, -1 is a measurement of less than that 0 point. So think about things like Fahrenheit, temperatures in Fahrenheit. We have 0 degrees Fahrenheit doesn't mean 0 temperature. It means we're at 0 on that line. -1 is 1 unit less than that 0 point. So 0 is just a point on that number line. It doesn't mean that there is absolutely nothing, or it's not a starting point. Some example here, we think about times or different values within our days, or a 0 point. So if we say that 0 is 0, and then 1 year later is 1 AD, and then 1 below is 1 BC, that 0 is arbitrary. It's arbitrary on that number line. It is where we picked as 0. Everything before is on one side, everything above is on the other side, but 0 is just a point on that line. It's not where things begin and not where things end. So think about temperature in Fahrenheit. -20 and 10 are 30 units away from each other, and we have a arbitrary 0 point that we set. Okay, we set that as 0, and we move from there. For ratio scale, we have an interval between each one. It's the same interval similar to during interval scale, except there's a true 0 point where that's the starting point. So there's an absolute 0, so that means there is nothing 0. There's no negative in this sense. So think about things like heart rate. You can't have -1 heart rate. You can't have -3 kilograms of mass. You can't have less than 0. So like blood pressure, you can't have negative blood pressure. So some of these have a definitive 0 point, like your height. You can't be -2 feet tall. So 0 means absolutely nothing, compared to an interval scale where we can move along that line, and 0 is just a point, an arbitrary point on that line. Okay. So a lot of things that we'll use in this class, a lot of our measurements will be interval, and then some will be ratio, but we can always use mathematical equations like addition, subtraction, multiplication, some of our other statistical tests to analyze these numbers. We can also alter these numbers. If we're in kilograms, we can change kilograms to pounds. Okay, if we're using feet, we can transfer it to meters. We can use mathematical equations to alter these. Some of those in your first lab, those math equations, used interval and ratio scale numbers. Like for BMI, you used height and weight. Height and weight are both ratio scale values, and we use them to calculate BMI, which is another ratio scale value. So we'll take a little pause here. You can stop, you can go through this. This is some time for you to go back and review, and then you can move forward in the next section. Okay. So I want you to go through these, pause the lecture, take a stop, take out your notes, and I want you to go through each of these 10 individuals with their 5 variables: sex, age, number of siblings, workout time in minutes, and if they have a job, and identify which scales each of these variables are. So think back to those scales: nominal, ordinal, interval, ratio, which is which. Okay, so pause and go ahead and try. All right, so we'll go through the answers here. If you didn't stop now, and go through this. This will help you practice. I promise it's going to help you later on for your quizzes, your exams, and so forth. So sex, that is a nominal scale. So we have either or, we have categories. They're not different, or they're different from each other, but they're not separated by a certain order. One is not above the other, and we can't use mathematical equations to compare or do anything with them. They're non-numerical, they're categorical. Age is a ratio scale. We can't be negative years old. 0 is a 0 age. So that's a ratio scale. Number of siblings, okay, that is also a ratio scale. We can't have less than 0. Workout time in minutes would also be a ratio scale. Okay, we can't work out for negative minutes. 0 means the absence of, in this case, time. And then having a job, yes and no, is categorical, so that is a nominal scale. Here's another example for you. You can pause and go through this one. Okay, now we'll go through the answers. Sex, as we went before, that is nominal. Age, that is ratio. Number of siblings, ratio. Workout time, also ratio. Work, ratio. The amount of units someone is taking in their courses, also ratio, and their major would be nominal. Okay, so we can go through these. You can practice them. You can see by thinking, is this a category? Yes or no. If it is a category and you can't use mathematical equations and it's not ordered, you know it's nominal. If things are ranked in order, okay, ranking 1, 2, 3, 4, 5, within that group, so out of these 10, which is first, which is second, which is third, that would be ordinal scale. If we're looking at if it's a continuous variable, is it interval or ratio? Think, is there an absolute 0? Does 0 mean the absence of information or the absence of this variable? If it does, it's ratio. If 0 is just a piece of that line, it's arbitrary, it could be wherever, then you know it's an interval scale variable. Right? This is our first mini. We'll go on or actually we'll just keep going from here. You can pause, take a break, and come back if you need to. Okay, so now what do we do with this data? Okay, we first have to organize this data. So say we have test scores, we have 10 points, or 10 points total, that's a perfect score, and we have 20 students. So here's our scores here. What are we gonna do with this? Okay, how are we going to organize this so we know what to do? Okay, so first of all, I recommend putting them in a sensible order. So maybe best at the top, so highest to lowest, or lowest to highest. So think about it value based. So if 10 is perfect, put 10 at the top. Or if you have something like times in a race or golf, maybe lower numbers are better, put those at the top. Okay, so we have all of these numbers. Now we want to kind of look at, we can just put them in order, but that just tells us, okay, we have all of these numbers. Okay, with all of these numbers, it's a little easier if we package it a little bit better. So we can use a frequency distribution chart. This tells us how often something happens. Frequency means how often. And then we can calculate the percentage of that. So how frequently it occurs in numerical values, and then as a percentage of the total. Okay, so we use this frequency table. So I want you to create a frequency table for yourself. You'll pause this. How you'll do this is you'll put each individual score that's possible. Okay, so 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And then the frequency is how many times that occurred. Okay, so if 10 happened, we'll go back here. say we count through, 10 happened twice, so the frequency would be 2, okay, and so on through each of these values. So like 1, 0, 2 happened 0, 3, 0, 4, 1, 5, 0, 6, 1, 2, 2, and go from that along there. Okay, and then you'll calculate the percentage. Okay, so take the frequency. The frequency is how often it occurred. So 10 happened twice, and we have 20 total scores. So 2 divided by 20, that would give you 10%. So 10% of those scores were 10. So go ahead, practice, go back through those. This lecture is posted up on Canvas, so if you want to go through it there, it's in PDF form. You can go through that also. Okay. So here's another option. We can go through here. We can look at what we looked at before, our sex, age, siblings, workout time, work hours, units, and their different major. And then we can create a frequency distribution chart for that. So we would take the variable, each score that's available, and then calculate the frequency that that variable occurs. So for example, sex, we have female as possible and male as possible in this situation. So we have female, we count them 1, 2, 3, 4, 5, 6. So female would happen 6 times. Male, 1, 2, 3, 4. Male happened 4 times, so their frequency is 4. So I want you to pause in your notes, go through each of these variables, and calculate the frequency that each of these variables occur. Ready, go. All right, here's an example of our answers. So you can go through, you can check your answers here to make sure that you calculated your frequency correctly. Okay, so here's another example. We'll go through another one. A lot of these lectures will give you examples so you can practice along with the video. So we have a quiz here. We have for 20 students that we had before, and we want to calculate a frequency distribution chart here. So we have all of the scores that occurred in this situation, and then the frequency at which they occurred. Now with this, we need to calculate the percentage at which each of them occurred. So we know that there are 20 total scores because we add the frequency of scores. So how often something occurred, sum them up or add them all together, and that'll give us our total number of scores, which was 20. Okay, and then we would use the frequency divided by the total to get the percentage. So frequency divided by n. N is the total amount of participants or total amount of variables. And we would go along through here, calculate them on your own, and then go back through this. Okay, I have your answers here. So this is how we would calculate our frequency and our percentage for each of these variables. Another example of how this is really used in kinesiology, an example would be the fitnessgram test for high school students or middle school students. In this case, we're using 5th and 7th graders. We have each of their variables, which would be their aerobic capacity, body composition, abdominal strength, trunk extension strength, upper body strength, and flexibility. These are the measurements. The tests could be the 1-mile walk. They could be a BMI. Abdominal strength could be number of sit-ups. Trunk extension strength could be back extensions, and then so on. Upper body strength, maybe push-ups. Flexibility, maybe it's a sit and reach. But we look at this in the total amount tested, and we have a criteria of what is in the healthy zone, in the healthy fit zone, or not in the healthy fit zone. So we would take the percentage that fell above that criteria. So maybe the abdominal strength number was you have to do 50 sit-ups. Okay, for this example, we'll use that arbitrary number, 50 sit-ups. 74.9% scored above or 50 or more sit-ups, 25% got less than that. So this describes what the population looks like. We have 75% almost of our 5th graders that have adequate, healthy, fit abdominal strength and 25% that don't. Comparatively to flexibility, we're about 50-50. Half of them have adequate flexibility or healthy fit criteria, and then 50% that don't fit that criteria. And we can compare that to our 7th graders, look at that population. We see that the 7th graders, a higher percentage of them fit that abdominal strength, healthy fit zone compared to our 5th graders. So maybe they're getting stronger, and maybe they're a little bit more flexible than their younger counterparts. Okay, so those are some examples of how we would use this information, use those percentiles to compare and to describe, using descriptive statistics, describe what's going on with that population. Okay, percentiles is another way that we can do this. This is ranking those percentages. So for an example would be a 90th percentile would mean that 90% of your classmates or 90% of the people in that measurement scored below your score. So 90th percentile means that 90% were below that value. 100th percentile would be the very top. 50th percentile is the very middle, so 50% scored above, 50% scored below that individual score. Okay, so 90th percentile, you scored better than 90% of the individuals in that group. Okay, if you think back, what kind of referencing this would be a norm referenced example. So we're comparing to that group, comparing to what's normal or what's within that group. So if we look at this here, we can look at a cumulative percentile and look at these scores. So we calculated the percent that each of these scores, the percentage that they occurred. Now let's look at the percentiles. Let's look at where they scored comparative to each other. Okay, so 5%, we start from the bottom in this case because 10 is the best. We'll start from the bottom. 5% or the 5th percentile would be a score of 4. Okay, and then we add the percentile above it, so the better percentile. So scoring 5 would also be 5th percentile. If we scored a 6, because we see that 15% of individuals scored a 6 or below, that would be our 15th percentile. Okay, and continue to add a 7 out of 10 in this test would be 30th percentile, because we see 15, 10, and 5. 30% of individuals scored that score or less. And then we add in 8, 9, and 10. So scoring 10 out of 10 would be the 100th percentile, so you're better than 100% of the individuals. Okay, 9 would be 90th percentile. You scored better than 90% of the individuals. Okay, and so on and so forth. Okay, this is why we organize scores in this way, so high to low or low to high. How we do this, or how we organize our data, matters, because if we're looking at what's best and we're trying to calculate the percentile, we need to know where to start. Okay, we want to start, if high scores are more important, we start our cumulative percentile from the bottom. If lower scores, if they're listed low to high, the cumulative percentile would start at the top. Okay, so for an example here, we have our scores listed from low to high, and high is the best. Okay, this would be our top-down model, so low to high, and we want high, so high is the best. Okay, we look at the percentage that it occurs, and we add the previous percentile there. So 1.5 percentile would be a score of 41. Here we see that 4.6 plus 1.5 would give us a 6.1 percentile, and so on and so forth throughout our example here. So this is how we would organize our data and give a little bit of descriptives into our percentile ranks. So we can compare an individual score to the rest of the population that took that exam. For example, this is used for GRE scores. The GRE is kind of like the SAT test, but for graduate schools. They look at percentile ranks compared to everybody who took that exam. And a percentile rank, if you are above the certain score for that university, they'll allow you within that program. If you're not above that percentile, you're not better than 55% of the individuals. If you're not 55th percentile, you may not be able to enter that university. So that's some things to think about and why this is important and why we need to understand what these percentile ranks tell us. They tell us where you stand compared to that population and how many or what percentage of the population scored above and scored below your individual score. All right, thank you very much. This is our first mini lecture for descriptive statistics.